It's working. It's working. So each block exists as its own thing. They're all square. So that's something I could change easily. I could make them rectangular and then double up one of the dimensions in my calculations. I might add that later. What I want to do is I want to have kind of regions of the city that are connected together. So like some of the blocks are parks, some of them are municipal buildings, stuff like that. I want it to be random but consistent. So like if you go back to the same place, it has the same stuff. Or if you load the same city with the same starting point, you see the same stuff. One way you can do that, something that's commonly used for generating terrain and random environments and stuff like that, is Perlin Noise. And so I've made a script here. Let's call this Perlin City. Okay, so that's generating a script. I'm going to get rid of these blocks for now. The way this works, I want it to have like different types of city blocks that it can pick from. So it'll pick a particular city block, and then it'll pick a particular version of that block, and then it'll pick an orientation, like a direction for it to face. So first I'm going to make some enums. First one I'll do block type. So this will be like what types of blocks am I spawning here? And I'm just going to copy and paste these in. So I've got my spawn point, that's kind of the default. Parking lots or parking garages maybe. High density residential, municipal, medium density residential, medium density mixed. Parks, special, I don't know, like might do like stadium or power plant. High density commercial and very high density commercial. I figure these are kind of typical city blocks. So it'll pick one of these using Perlin Noise. Perlin Noise is random noise that is smooth, meaning random selections from regions that are near each other are going to be similar. You can control how much it varies, how quickly that gradient changes. So think of it as like a map like this. This is a good example. It goes from 0 to 1, whatever the bottom to the top of the randomness scale, basically. So you get ridges, you get mountains and valleys, and you can combine these together to get all kinds of different effects. You can define regions, you can do 3D space. It does all kinds of cool stuff. You can use it to generate terrain, clouds, galaxies, maps for games, all kinds of stuff. I'm going to use it to generate a city here. All right, I'm also going to need orientation. This is just going to be north, east, south, west. Okay, so I'm also going to create a class here. And a Perlin City block has a type, an orientation, int, selection. So in my city, let's see, first one I have, whoops. All right, so I'm going to make a dictionary to keep track of all of the blocks that have been loaded. I can add other properties to my city block here and keep that information as well. I also want to keep track of which blocks I've loaded. So this way, I know I have a reference of which of these blocks are actually loaded and in the scene. I can also remove them from the scene if they shouldn't be loaded. So I'm going to need a separate list. I don't know if I need this per se, but the way that I have thought about this and the way that it makes sense to me, I need this. So I want another list of local blocks. And those are blocks that are near the player that should be loaded. And that's a slightly different list than the list of blocks that currently are loaded. I also need to keep track of block width. So all my blocks are squares. They're 110 meters wide. And I want to keep track of the player's last position. This just keeps track of where the player was recently. So when it checks to see which blocks should be loaded, it uses that. So it only does it every so often. Only if the player moves a certain distance away from their last position, then it resets the last position and checks to see which blocks should be loaded. That's how this is going to work. I think it'll make sense here in a second. Next, I want to make a couple of public properties, and I'm just copying these in here. So I need my arrays of city blocks. These are the actual blocks that I'm going to use, that I like the prefabs that I make in Unity for a city block. So these are different parking lots, high density residential areas, high density commercial areas, and so on. So when I go to spawn a block, this is where it's choosing them from. So the way Perlin Noise works, you can sort of stretch it or shrink it. You can sort of modify it by multiplying the coordinates that you're using to get the Perlin number by some other number, by an amplitude. And you can also shift it by some phase. So I'm going to make a method. Let's see, what is this? This is going to get a Perlin number at some point ij. This is like a coordinate in my map system. And then there's going to be an x amplitude and a y amplitude, and then a float x phase, y phase, and that's all I need for parameters. I'm going to say return mathf.perlin Perlin Noise, and by default I could just get ij, and that would get me the z coordinate, or whatever you want to call it, of the Perlin Noise at this point. However, I can multiply both of these by different amplitudes, and it'll kind of stretch or shrink the Perlin Noise field to be more noisy, more precise noise, or smoother and broader and more spread out. And I can also change the starting point. How far up or down or across, left or right, does it start from? So that's the phase. So I multiply by the amplitude and add the phase. Multiply by the amplitude, add the phase. And that'll give me some Perlin number. And, you know, in fact, I'm going to make something a little bit simpler to I'm going to combine all these. So I'm going to make a class called Perlin params. I'm going to make this serializable. Public float x amplitude y amplitude. Let's give it a default value of 1. And then phase equals 0. Y phase equals 0. Okay. And then change this to Perlin params. Oh. Okay. Just call pp. And I say pp.xamp, pp.xphase, pp.yamp, pp.yphase. There we go. So I also wanted to add another type of Perlin noise that I don't know if this is a thing that somebody else has already come up with or if I just invented it, but this is my idea. I call it Perlin plaid. It's where you take so you take one dimension of Perlin noise. So imagine you have like some Perlin noise space and there's just, random whatever. Imagine taking a slice of that at one particular point. There we go. So that'll give you some kind of wave or function or whatever. It gives you a one-dimensional Perlin noise, basically. And you could do the same thing going the y direction. You can create these two different dimensions of Perlin, one-dimensional Perlin noise. And you can create regions between these, depending on how you have your, you can say like when it's greater than or less than certain thresholds, you can define regions between these two dimensions and you get kind of a plaid pattern. And you can say when it's above a certain point in this one and below a certain point in this one or whatever, you can sort of color these differently. Imagine what that would look like. So the reason I did this was I wanted kind of rectangles and square regions in the city so I could have parks and things that are kind of together in rectangular sections. So the whole city doesn't have to follow that exact pattern, but I wanted a way to do that, and Perlin plaid is one way to do that. So I have an example of Perlin plaid here already. I just call it minimap, and I put some colored cubes in here just as a demo. So here's an idea of what Perlin plaid looks like. And so you can kind of set up the way you use these regions so that adjacent regions make sense to be adjacent to each other, but regions that are very different, you can have you can kind of guarantee that they won't be next to each other. Like the turquoise and red should never touch, or turquoise and purple. They'll be sort of close to each other sometimes, but they'll never be right next to each other. All right, so I'm going to make another method here. And it's just going to be an integer that's like, what region are you in? Probably better ways to do this, but for my purposes, this is good enough for now, and I can generalize this or come up with a better version of it later. I'm going to make another Perlin plaid params. Oh, you know what? I don't need to have two different objects. I can just have it on the same one and just not use it in the other one. Let's call this X pattern. That can be 0 by default, doesn't really matter. Public float Y pattern equals 0. So that's going to determine like where the X and Y slice is taken out of the Perlin noise, basically. So how that where that one dimension is defined. So if you move that slice up or down in the noise space, you'll get a different pattern, a different function along this axis. So this is also going to have Perlin params that it returns. So this is going to work a little bit differently. Here I want sort of one-dimensional parameters, kind of a x and y, and define regions. The way I do this, well, I can copy this. For this, oh no wait, I want Perlin params, that's right. Y pattern. So the x value is based on I, and the y value is fixed based on the y pattern. So that's our slice of the Perlin noise. And then for the y, it's the opposite. We use the x pattern. So x is fixed, but the y varies. All right, so this tells us what region we're in. So I'll do math f dot round to int. I'll round x times 3. So that's going to be a number between 0 and 3, excluding 3. I'll multiply that by 3, and then add y. So if this first number is 0, it'll be 0, it'll be 0, 1, or 2. If this first value is a 1, then we'll start at a 3 here, so it'll be 3, 4, or 5. Yeah, 6, 7. Okay, so we'll go 0 through 8. All right, does that fit with 0 through 9? Oh, I can do 1 plus. If I want to ignore the default value, if I want to skip the 0, I could also set this equal to 1. I could also do this. I could also just keep it at 0 for a parking lot. I don't know. There's a bunch of different ways to do it. I want to keep this at 0, do parking lot as 1, and then, yeah, so when I pick which type of block I'm going to put there, I'm going to do it this way. Start with 1. So now I want to get a block based on which type it's going to get. So let's say public Perlin City block, get block, yeah, get city block. I'll call it. And that's going to return some city block, which is what these are. I need to pick which set I'm going to draw from. So I'm going to say Perlin City block array blocks equals, let's do, given a block type, we'll choose based on the type that we're given. You know, I'm just going to copy these over. If it's a residential type we're looking for, we want the residential blocks, and so on. All right, so now that we know which set of blocks we're going to be choosing from, I need a way to choose. So I'm going to need some Perlin parameters up here. Perlin params. Let's do selection params for choosing which block, which city block from the set to use. We need the orientation. and then the region, let's call it. So next I'm going to do I need a way to choose which block I'm going to get from this group, and also let's just do this. I'll have my selection. I'll assume this knows which one I'm trying to choose from the list. That's fine. So I'll say return blocks in selection, but some sets I might not have. Let's say I choose selection number 4 and it's a set where I only have 2 blocks. So I'm going to do percent blocks dot length. So it's only going to get the remainder. So if like I choose number 4 but I only have 2 blocks in there, it's going to choose the second one. If the index is 3, 3% 2 will give me 1. Okay. That works. So I'm going to do get selection from some point. So I'm going to say int I, int j, Perlin params. So let's get a Perlin number first. Get Perlin ij pp. That's pretty easy. And then I want to adjust that because I found that the Perlin noise numbers are not really, they tend to be, there's like a bell curve distribution, I think. The probability of getting a 1 or a 0 or a number very close to 1 or a number very close to 0 seems to be pretty low. So I'm going to go for the decimal points that go after that. It's a little bit more random, a little bit better distribution. So I'm going to adjust this. So I'm going to say float k adjusted equals k times 10 percent 1.0f. So what that's going to do, I could even do 100. It's going to multiply my Perlin noise by, or my Perlin number, it's going to multiply by 100 here. And then it's just going to look, it's just going to lop off any whole numbers and just give me whatever the decimal number part of it is. And so that's my adjusted k there, so it's a little bit better distribution. So then I want to take that whole thing, multiply it by 4, so I'm getting a value between 1 and 4. If I want to have more selections, or if I want to change how this works, I could change this number. This is just how I've chosen for this to work. Floor to int k adjusted times 4. So that should give me a number between 0 and 3. So 0, 1, 2, or 3. So now I can get a random selection. That same thing works for orientation, since there's 4 possible orientations as well. That works in both places. So let's get the full block with all the properties. So I want to get a random block, and that's going to be going to come from my plaid. Let's see, I need a I and j here for my coordinates. This is where I'm putting this block. And I'm going to use my region parameters to figure out what type of block I'm going to get for this point. And then I get an orientation. Oh, I think it did it for me. It keeps starting to do it, and then there we go. Except not plaid. I just want a regular Perlin. Oh no, I want get selection. And then selection params. So those are different parameters, so that Perlin map could be a little bit different. Because if they're using the same one, I find you get a lot of repeated kind of stuff. So if you're having your different parameters chosen by different Perlin maps or different Perlin parameters, then you get a lot more like variation in noise and it looks a lot more natural. So that's kind of the key to getting a lot of complexity is by overlapping Perlin noises in different ways. Okay, so last thing I need, int selection equals get selection ij selection params. Oh, oops, this is supposed to be orientation params. There we go. Those are the three pieces I need. So I can say get city block type selection, if I can spell correctly. And then I need to give it an orientation. So they're facing a different direction depending on that Perlin noise. And I think that's everything I need, and I can return that block. So I need to actually place the block in the world. These don't need to be public. Private spawn block. So this is actually going to place the block in the world. So I need a block and then where to put it. Okay. Oh. Alright, so my spawn block method is going to take that city block. So float x equals I times block width float z equals j times block width. So these are the actual world coordinates where this city block is going to spawn. So then the spawn position is a new vector 3 x 0 z, like that. That's where it's going to go. Next I need to get the rotation. So the rotation angle is going to be block dot orientation times 90. Since this is an enum, it's also an integer. Yeah. Quaternion rotation equals Euler 0 angle 0. So we've got the position and the rotation and the object. So now all I need to do is instantiate block at that position and rotation. Easy peasy. I'm also going to add a method to save block to the dictionary. I'm going to copy and paste this one. There we go. So I'm going to add a block to this dictionary just to keep track of which blocks exist in the city. So I'm using a dictionary. Dictionary has a string as the key and a city block as the object that it stores. So this is how I can add properties to it to keep whatever information I want in the city. So like if there's items you can pick up in the city that can spawn randomly or something like that, I can keep track of whether or not you've already grabbed that item with these custom properties. If you like leave the chunk and come back to it. So I'm also going to have this method generate and spawn generate and spawn block. Let me just change this real quick. Oh yeah, so I want to return the actual block that I'm instantiating here so I can save it. So here I actually get the block, spawn it in the world, so it actually places it in the game, and then saves it to our dictionary. I also need to load a block, and this is going to be at a particular point, ij, and then again I'm going to get a string key here that's just I comma j as a string like that. So I'm going to add it to the list of loaded blocks. This should be, did I have, oh, local blocks. Should also be in the list of local blocks if it's being loaded. So if our dictionary already has this block, or if we already have this block loaded, if it already exists, then I can say spawn block city map key. So it'll grab that block, I, j, and place it in the world. But if it's not in the dictionary, then I need to generate it from scratch, which I can do here. And that will put it in the dictionary as well. Similarly, I need to be able to unload a block. So if it gets too far away from the player, I'm going to remove it from the game. So we need to figure out which block we're removing. I'm going to use the key that we've been generating, this guy right here, for that purpose. So we're going to grab that from the city map. There it is. And then I want to destroy block.gameObject. There we go. And I want to say loaded blocks.remove key. Okay. So at the start of the game, or at the start of the scene, I want to check the local area and see if any blocks, see what blocks need to be loaded. And this is going to be something that I can do every update as well. So first I need to get the player position. Position.x and the z, and then I need to check for loaded blocks in that region. Check loaded blocks x z. And when I check loaded blocks, near this point, xz. So this is now your last position. Every time it checks to see which blocks should be loaded in an area, this is the position you were in last time that check happened. So now every update it can check to see if you're far enough away from that position that it's worth doing an update, basically. So now I want to check local area and then unload if out of range. So I want to check to see if all the blocks in this area that need to be loaded are loaded, and if they don't need to be loaded, I want to unload them. And we have those methods set up already, so we just need these two. So check local area. It's going to work like this. So take those X and Z, the position of the player, I'm going to say player I equals math f dot round to int. This is going to be x divided by block width. There we go. And then for same thing with the z coordinate. So that's going to get the closest, or actually I want floor to int, don't I? I guess round is probably better for this. It's going to get the closest city coordinate, not like the actual world position, but like the coordinate in the city. And then I want to check over some area. Let's start 5 blocks away. So we'll say player I minus 5. Let's see. I is less than or equal to player I plus 5. I plus plus. And same thing with the j coordinate. J, player j, player j. Okay. And I want to load block ij. So load block, we already have that method defined. It's going to say this is a loaded block and a local block. It's going to check the dictionary to see if it's there and then spawn it. Otherwise, it's going to generate it and then spawn it. So check local area. Oh, I also want to say local blocks equals new. Or local blocks.clear. There we go. So that empties out that list of local blocks. All right. So now we can check the local area. And that'll set up our local blocks, which ones should be loaded, and it'll load them. And then we need to unload blocks that are out of range. Unload if out of range. And so now we have a list of all of the local blocks that should be loaded. So I can say if local blocks contains, oh, I need the key here. So if that local block is supposed to be there, then you can skip it. Otherwise, unload block key. And we'll use this method right here to unload that block. I also have the list of loaded blocks. So those are the ones I want to check. Let's see. For each, not local blocks. Loaded blocks. So it's going to check each loaded block and unload it if out of range. Oh. That's right, it's keys. Okay. So for each key in the list of loaded blocks, it's going to check to see if that one's supposed to be there, and if not, unload it. All right, so the last thing I need to do is this update method. So that's going to do the same thing here. It's going to get the player's position, and I'm going to say if the distance between your last position and your current position is greater than, let's say, block width divided by 2. So the block width is 110 meters, so this will be every 55 meters, unless that changes. Then again, check loaded blocks at x, z, or z, whichever you prefer. I think that's all I need to make this work. So now I need to plug in some values in Unity. So if you're going to do something like this, your city blocks would obviously be a Perlin City block or whatever, if you whatever you called your class there. I changed it back from Perlin City block to just city block because that's the one that I already made for testing purposes. So I'll just use that. So now you just need to define your selection parameters, region parameters, and orientation parameters. So I already have this worked out for the city. Region is going to be 0.5, 0.5, 20, 20. All right, so I've added some numbers for the amplitude and phase for my selection. Same thing with orientation. And in the region, this has some extra pattern parameters down here defined that defines the like where that X and Y slice is going to be taken from. Now I can just plug in all of my prefab, all my different city blocks here. Parking lots in the parking lot list. And then the player position is right here. They're going to be sitting in the sky car, the flying car right here. Okay, I've got my parameters defined. I've got my city blocks added to my lists here. Let's see if it works. Okay, so something's wrong already. I'm spawning inside a building, so that's not good. Where am I? Oh. Why? Okay. It's doing something. It's not terrible. Alright. We're getting part of the way there. Only some of the street lights are working. This feels kind of laggy. Something is not right. This isn't bad though. It's kind of working. Spawn the city. It's doing something. These lights are, oh, is it? Is it doubling up? It's doing something weird. I did something wrong, and I'm not sure what, because those lights are way too bright. I think it's loaded all these buildings twice or something. It's doing something really weird. So the problem's here. All right, I can't remove an item from this list while I'm looping through it. So what if I did this? Keys to remove. It's a new list. Let's make this a bool. Oops. There, like that. Okay. That's what I meant to do. Okay, so if it's supposed to be loaded, then return false. But if it unloads it, return true. So we could say if unload if out of range, then add that to the list of keys to remove. Then we'll say for each in keys to remove, then we'll remove them from the other list. Loaded blocks.remove key. There we go. So it doesn't actually remove the key. It just says, it just adds it to a list. It's like, hey, this one needs to be removed from the list because it's being unloaded. But it doesn't actually remove it from the list yet because we're not done looping through the list. Then once we're done, it says, okay, here are the ones that were removed. Now take them out of the list. So now it's safe to do so. So at the center, I want to spawn the start block, the empty parking lot, so I stop spawning inside an alley. I think that'll fix it. Oh, much better. There we go. Start up. Yeah, this looks great. It's working. It's working. I don't know why only some of the street lights are working. That's weird. But the city's spawning. It's doing it. And you can tell the rotation. Yeah, so here's the orientation algorithm at work. These two blocks are the same type. It's the same, the same selection and the same type next to each other, but different rotation. So sometimes you get the same thing in a row, but the rotation really helps, like, break it up and make it seem more random. You get, like, big sections and small sections and all kinds of stuff. Parks that look quasi-realistic, sort of. It's not terrible. You get, like, business centers with a lot of skyscrapers, and then you get a bunch of, like, smaller buildings in a row, kind of a medium density district. And it goes on forever. And I think it's actually unloading the correct blocks now. I don't know how much that's actually saving on memory. I'll need to do some tests to see how much that's really helping and if I can improve it. Render distance is a little bit better, but buildings are still kind of clipping the distance. I try to keep this pretty low poly so it's not, so the individual elements aren't too terribly taxing on the processor, so you can have a whole lot of them at once. Alright. Not bad. It's coming along. Definitely kind of sort of looks like a city. Alright, so I added something else. I had a random idea. I thought, what if I made something follow a path based on Perlin space, where the Perlin noise defines some kind of vector space? Because I've seen examples of this before where people use Perlin noise to define like an angle of rotation. So what I did was I thought, why don't I come up with 3 angles of rotation for 3D space? I don't know if that's totally necessary. I think I only need 2, but I did 3 because why not? So I made 3 angles with Perlin noise based on, this is the function that I made earlier. I just moved it to a separate class by itself called Perlin tool, and I made them static so you can use them from wherever. Just let's see. So Perlin Firefly takes the current position of the object, calculates 3 angles based on Perlin noise. So it gets some Perlin noise like this based on 2 position parameters, multiplies that by the maximum amount of angle rotation that you want it to have. So like a smaller maximum angle means smoother motion, less squiggly, and then a larger max angle means a lot more random looking squigglier motion. And then so it rotates the object and then moves it by some small amount, and they fly around kind of like fireflies. So that's why I call it Perlin Firefly. And it looks something like this. Oh, there they go. And it looks pretty random, but also kind of, smooth. They follow kind of a consistent pattern where sometimes they get stuck in going in circles for a little bit, but then they get out of it. Like, see that one right there. There he goes. He was going in circles for a little bit and then he stopped. And like sometimes when they get near each other, it looks like they're following each other for a bit. Like their paths will be similar briefly, but then they'll break up again because they don't follow exactly the same path unless they start at exactly the same point. Oh, look at that. That's neat.